Next up, we're continuing the LCA trend, very exciting, with Dr. Mohammad Wali, who's a postdoctoral researcher at the University of Helsinki and Hannu-Tuomisto's lab. He's going to be presenting an LCA of serum-free media. Thanks so much.
Oh, this is working, yeah. So, hello, I'm Mohammad, and today I'm presenting the work on the environmental impact of using serum-free media for proliferation of bovine satellite cells. There are a couple of people out there, many people actually, that contributed with data and unit processes and model design as well from these universities, University of Helsinki, from Nofima, and from Aarhus University. So the motivation of our research was basically to reduce or eliminate basically these concerns or these issues. So first was the ethical concerns, basically related to the slaughtering of pregnant cows and suffering of fetal calves. And the second issue, which is mainly the one that I'm presenting today, is the environmental burdens characterized by the climate impact and agricultural land use of fetal bovine serum. Of course, we're going to look at other impact categories as well. So what we are doing is that we are basically examining alternative serum-free media that have been developed in Nofima and Aarhus University. And we are testing those against the baseline scenario, 10% FPS. So the baseline scenario contains the 90% of the MEM F12 and 10% of volume of FPS. The first alternative was basically to reduce the FPS concentrations into 2%, where we are actually replacing the rest 8% of the FPS with again the MEM F12 and the essential 8 media. For the second alternative, we have introduced the protein hydrolysates into media, and we totally replaced the 10% FPS with the MEM F12 and essential 8. And of course, there are a couple of raw materials of protein hydrolysates that we examined. The first one was the eggshell membrane. Second was poultry residues and egg whites, pork plasma, and the last was the plant-based pea concentrates. And the last alternative was the tri-basal 2.0 ITS, standing for insulin transferrin selenium. And this medium was developed in Aarhus, and there's actually a poster out there explaining the advantages of this medium compared with the baseline medium. So it contained the growth factor, FGF, that Kirsten was explaining a little bit earlier, and Fetuin, bovine serum albumin, insulin, transferrin, and selenium. So here is our system design. And so basically we are approaching the system from cradle-to-gate approach. So we are really looking back in the upstream, including the extraction of raw materials, water sourcing, energy, and the production of chemicals. And the system boundary ends up exactly when we are actually producing 1 liter of culture medium. And of course, we are using life cycle assessment. And the impact categories we are examining are the following: global warming, energy demand, eutrophying emissions, including marine and freshwater eutrophication, water consumption, particulate matter formation, ozone formation, land use, terrestrial acidification, and fossil resource scarcity. And here we're going to look a little bit on the processes of the components of medium, basically. So for the baseline medium, for the production of fetal bovine serum, we have considered that the FPS is coming from the slaughtered pregnant cow blood. So first of all, we have considered refrigeration, and then the centrifugation to separate the serum from the other components of blood, plasma or something else. And then we have filtrated the serum in order to obtain the purified fetal bovine serum. The components of the protein hydrolysates medium, first of all, it's good to say that all the protein hydrolysates from all the raw materials followed the very same processes. So first of all, by introducing the raw material into the enzymatic hydrolysis, and then the thermal inactivation, and then the centrifugation in order to obtain the protein hydrolysates. And of course, the yield is different based on each raw material, in what material we choose. And this will also probably have a great impact on the environmental impact results later, since that, for example, for the eggshell membrane, we would need definitely more raw material in order to produce the required 1 kilogram of protein hydrolysate, for example, while we would need less raw material for protein for pork plasma, for example, that the yield is really the highest, 72%. So here for the production of the tribasal components. So for the Fetuin, of course, Fetuin generally might be taken from FBS immediately, but we followed the recombinant approach, where the mammalian cells were cultivated first, and glucose was also included, and then it was fermented and then purified via ultrafiltration in order to get the Fetuin product. For the FGF, basically the process was explained earlier by Kirsten, thankfully. And for the bovine serum albumin, we have used, we considered serum as the main as the main source, but the mass amount of bovine serum albumin was really very insignificant compared to the FBS. So I hope we can still consider this as a serum-free composition. So just going into the results, so here's the results of the baseline scenario. So you can already see that the FBS is really predominantly the main contributor to all the impact categories. Of course, all the others are components of the basal media, the MEMF12. And for the land use, for example, the main contributors were amino acids and glucose. And it's also good to mention that the amino acids also contained quite a lot of glucose as well. And glucose was obtained from maize, which, many of the land use for maize was allocated to the glucose production. So that explained why the land use in particular was mainly contributed by these two parameters. Now going into the comparison between the first alternative and the 10% FBS. So of course the first alternative included the reduction of FBS, and since that FBS of course is the main contributor to most of the impact categories, so this explains the overall reduction in environmental impacts, despite the fact that we were replacing the 8% of FBS with DME-MF12 and Essential 8, but that didn't really cause any exacerbation of any of the environmental impacts. And of course, land use is still a little bit the same or decreased a little bit because the main contributor was really not related to the fetal bovine serum. So for the tribasal medium, this really was a lot of reduction can be observed over here, and you can see that the main contributors for the tribasal is of course the amino acids and the glucose, as well as the growth factors that have been introduced before. And but generally speaking, even the growth factors did not have any contribution, or a little bit contribution in most of the impact categories. Okay. And here the comparison between the 10% FBS with the protein hydrolysates media. So I'm sorry for the grammatical mistake here. It's not membrane, it's membrane. So the first, So generally the reduction was already all over there, except for the eggshell membrane, where in the energy demand, for example, it really exacerbates the energy consumption. And it's also good to mention that overall the protein hydrolysates from eggshell membrane was the worst performer among other protein hydrolysates because, again, if you remember earlier, we have talked about the low yield of protein hydrolysates from eggshell membrane. That explained why we actually needed more raw materials. And you can actually see the contribution of raw material for the eggshell membrane specifically. So, yeah. Okay. And here we actually tested the sensitivity to the allocation choice of material, of outputs. And we have realized that, for example, by switching from economic allocation mainly in simple words mean to allocate the environmental impacts of the process based on the economic value of the output. So by switching into the mass allocation, so that means that we are actually allocating based on the mass of the output. We have realized that the 10% FPS is really the worst, and that's because the allocation for the FPS going from economic to mass allocation is actually makes really very big differences, that the economic value of the FPS would really be much less compared to its mass output. And another sensitivity assessment was related to the electricity inputs. So we have actually studied the changes compared with the finished grid mix. We found that renewable energy sources were actually the best performers. There's always a room of improvement for reducing the environmental impacts of protein hydrolysates. For example, this graph is related to the protein hydrolysates production because energy was a major contributor to the environmental impacts overall. And key takeaways is that the all studied serum-free media reduced most environmental impact categories. The protein hydrolysates media from egg whites, pork plasma, and pea concentrates were the best performance overall compared with all other alternative media. And the tri-basal 2.0 ITS had the highest climate impact reduction, and there's always room of improvements for protein hydrolysates when renewable energy is actually being utilized. And I would like to acknowledge Kone Foundation that have funded my work in the University of Helsinki. And thank you very much.
Thanks so much. Do we have some questions? Yeah, John has one.
Thank you for the talk.
Yeah,
I just had a small minor question. I saw that solar had a high freshwater eutrophication.
Yeah.
Is solar bad or like?
Yeah. Oh, probably that's okay. So that was because of the phosphorus leakage from the establishment of solar panels. I did not understand the main reason of that, but yeah, eventually the establishment of solar panels, they produce phosphorus runoff from the soil. Yes.
Interesting. I also never heard of this before.
Yeah, me too.
We have another question. I'm so sorry. You're going to have to throw, but maybe we can do Kirsten in the middle. Nice.
Thank you for that great talk. I was wondering how you inventoried FBS, because it's made up of a lot of different unknown concentrations of growth factors, hormones, etc. So yeah, what did you use for inventory in terms of like flows and all that?
Well, actually, it was really from the blood that's slaughtered from the pregnant cows, and then they were just, and of course the assumption was that there are two main components, the serum and the plasma, and the centrifugation was actually assumed to be separating both, and I don't think we did really look into details into the components of the FPS at that point.
It's a nice strategy to like treat it as a as like a bulk, one ingredient, as opposed to a collection of components.
Yeah.
Cool strategy.
Yeah.
I think there was one more question in the corner.
Thank you. I was wondering, in your serum-free media formulation, what the contribution of the remaining animal-derived components was versus the rest?
Basically, I have yeah. So probably you mean this one, or which alternative media you probably?
So I think you had albumin and Fetuin inside.
Okay, yeah, yeah. So for example, this is the yeah. So I actually combined them with the growth factor thing. So it's so yeah, we have bovine serum albumin and we have Fetuin, but the contribution was really that was mainly the contribution of all of them. So the contribution was really low, because also it's important to mention that the mass contribution of these was really low as well, which was
Thanks.
yeah.
Cool. Thank you guys so much for your questions. That's unfortunately all the time we have, but let's give another round of applause for our speaker.